you're to differentiate y equals x squared sine x plus tan inverse of 2x. Now, you can see here that this part requires the use of the product rule, alright? Because we have a function of x multiplied by another function of x. This part will require the chain rule because it's a function of a function. 2x is a function of x, and tan inverse of that is another function of x. So what we have here is that the 2x you can consider as the inside function, and then the tan inverse of that as the outside function. Now, if you've been practicing your chain rule and product rule regularly, you'll be able to do this quickly. In some part of it you do mentally, but let me assume that you have not been practicing that. Let us say that this part, let's give it a name, call it y1, and let's give this part the name y2. So we just break it up into different parts and look at each part separately. We have y1 is equal to x squared sine x. Alright. Now the product rule. We differentiate this part first. The derivative of y1 with respect to x, that's dy1 by dx, is equal to, remember, one of the functions that's in the product, you hold it as it is. We're going to hold x squared as it is, then find the derivative with respect to x of sine x, plus you hold the second one as it is, we hold sine x as it is, times the derivative with respect to x of x squared. Alright? So that's the product rule. Remember, when you have the derivative of uv is equal to u dv plus v du. Alright? You have two products multiply one another. Hold the first one time, multiply by the derivative of the second one, plus hold the second one, then multiply by the derivative of the first one. Or you could hold the second one, differentiate the first, plus hold the first, differentiate the second. But the point is that you hold one as it is, differentiate the other, plus hold the other as it is, differentiate the one that you didn't differentiate first. Now, what's going to happen here? So dy1 by dx is equal to x squared. You're not going to interfere with x squared, but you're going to differentiate sine x. What it is the derivative of sine x. Let us look at our formula sheet. We have it here. When you differentiate, on the left you have the function, on the right you have the derivative. So when you differentiate sine x, you get cos x. So this is going to be x squared times cos x plus sine x is as it is multiplied by, when you differentiate x squared, you get 2x. Okay, good. Let's keep that as it is. Let's deal with this part now. y2. y2 is tan inverse of 2x. y2 is tan inverse of 2x. Now, let's find the derivative of y2 with respect to x. Okay, hold on. It's a function of a function. So let's use a substitution then. let u be equal to 2x. Alright, so in that case, we would have y2 is equal to tan inverse of u. You see that? Now, dy2 by dx. The chain rule here, what you would get is the derivative of y2 with respect to u. So it's dy2 by du times du by dx. I use the dot instead of the multiplication sign. Notice you could cancel du and du, and leave the dy2 up top just like this, and the dx down the bottom just like this. So you see everything cancel out nicely. Alright, we need to find dy2 by du and du by dx. Let's find du by dx first. What is du by dx? Well, u is 2x, so du by dx is going to be 2. Using the power rule is 2. Now what about dy2 by du? What is it? Tan inverse of u. Let's check our formula sheet. Alright, our formula sheet is not tangent inverse of x that it shows. It shows a cotangent inverse of x. Right? I don't know why they leave out the tan inverse of x. Probably to just give you a hard time, but anyway. The thing is, we have cotangent inverse of x. However, the only difference between the derivative of cotangent inverse of x and tan inverse of x is the sign. The negative is no longer there, it's positive. So the derivative of cotangent inverse of x is negative 1 over 1 plus x squared. The derivative of tan inverse of x is positive 1 over 1 plus x squared. So try and remember that, alright? They didn't give it in the formula sheet, but you can remember that. Try and remember. So it's 1 over 1 plus x squared. Although it's not x we're dealing with here, it's u. So it is 1 over 1 plus u squared. Alright? Now let's substitute the values into dy2 by dx. dy2 by du is going to be 1 over 1 plus u squared, that's dy2 by du, times du by dx is 2. So what we have is 2 over 1 plus u squared. But then the thing is, we did not get the function with any u in it. We're the one who had put it there, so we need to remove it and restore the function to the previous form. What was u? U was 2x. So this is 2 over 1 plus 2x squared. Alright, let's put everything back together now. We're finding dy by dx. So dy by dx is equal to, so remember, all of this is y, We found the derivative of this part. What was it again? dy1 by dx. dy1 by dx was x squared cos x plus 2x sin x. So it was x squared cos x plus 2x sin x. I put the 2x over on the left hand side, right? And then we add the next part to it now. Remember, we have this part we call y2 and we differentiated it. The derivative of that part is 2 over 1 plus 2x all squared. But then guess what? The We don't need to put everything here in bracket and so on. Notice 2x all squared means 2 squared by x squared. 2 squared is 4, so you could just write it as 4x squared. Alright? Okay. So there we go. Alright? So that is our solution.